Okay, so the next question that we got on the menu today is asking us, does a particle that moves around a circle at a constant speed experience an acceleration? The short answer, absolutely yes. But the long answer, well, let's actually draw some diagrams and kind of like show experimentally or through drawings what would be going on and why this is the case. Okay, so suppose that we have a circular path that looks like this, nice and circular, and we got a particle that's looking like this that travels in a circular path. Like right here, its velocity would be this way, and it follows that circular path. It really is going round and round, kind of similar to, like, imagine you're driving a car inside a roundabout. This would be like a similar situation. Okay, now let's define acceleration. Acceleration is change in velocity with respect to time. And let's specify that these are vectors. So changing velocity with respect to time, we can also say that both or either the magnitude and direction can be changed. Okay, what that means is, you know, we typically think of acceleration in terms of like linear acceleration. Like, you know, when you're driving, you hit the gas pedal, that causes an acceleration because you move forward faster. But every time that you make a turn while also maintaining your speed, you have to be accelerating towards the center. So the velocity is going to be changing. So at this point in the loop, the velocity might be looking like this. When you're down here in the loop, your velocity might look like this. Over here, your velocity might look a little something like this. So your velocity is always like curving towards the center of the circle, really. And what's causing that is an acceleration. There has to be an acceleration going inwards. So typically it's called the centripetal acceleration, AC. Centripetal acceleration. Curves velocity towards the center of the circle and stops the particle from just continuing in a straight tangential line. Prevents the particle from continuing in a straight tangential line. Okay, so that's the acceleration that a particle will experience when traveling around a circle at a constant speed. Okay, and the equation for centripetal acceleration is velocity squared. So AC is equal to velocity squared over r. R, of course, is the radius of the circle. And associated with every acceleration, there's typically a force. So we just multiply this by mass to get the centripetal force that keeps it inwards. Okay. And yeah, so the above solution is good. Yeah, and centripetal acceleration is always perpendicular to the angle, or is always perpendicular to the velocity. Okay, that's a good thing to note, and you'll see that more the more you see like dynamics and motions across curves. So the above solution is good. Cool. Ain't that a beautiful